I'm going to full screen mode. Anybody knows how to come back? Please let me later on. Okay. See here. Can you read this?
Yes, sir.
Yeah.
Yeah.
Somebody read it, yeah?
A direct mail firm wants to determine if the mailed advertisements resulted in the response rate difference from the national average of 6.5%. The random sample of 1,000 households is chosen to receive the advertisements for this new product. After 1,000 household samples, 85 make a purchase. Researchers decided to use the test and interval based on the normal distribution.
Okay. Now he says, a direct mail form found that response rate different from the national average of 6.5. That is, national average is 6.5% response, right? This is a population proportion or a sample proportion?
Sample proportion.
No. Population.
National average, right? So 6.5%. So our null hypothesis is what is happening, Gita principle, 0.065. Right. So alternate hypothesis is it is not equal to 0.065. If you want, you could take one tail also. Accordingly, it will vary. How to do that? Probably I will teach you on Thursday class or Tuesday class. Right. Now, random sample of 1,000 households. What is the sample size? 1,000. Is chosen to receive advertisement for this new product. Of the 1,000, 87 made a purchase. So what is the now? What is the average now here? Sample average proportion. Sorry, average sample proportion. 87 by 1,000. Okay.
Yeah.
So 87 by 1,000 is 0.087. So since I'm using proportion, it should be less than 1, right? 0.065, 0.087. Clear?
Yes, sir.
Okay. This also you can feed in. Here also you can feed in any value. Then what happens? Here, the Z value is calculated. The sample proportion, that is 0.087, minus population proportion, we know, right? So this is the null hypothesis. It's always true. So PS minus P naught, this is the deviation. We want to check this deviation only. We are saying that we are bringing it to inferential distribution, 0 mean. Okay. Divided by square root of population proportion into 1 minus population proportion is the variance divided by n. Square root is the standard error. Therefore, this is nothing but sigma by root n. Therefore, with the population proportion, we can get this accurate Z value. Okay, clear?
Yes,
numerator PS minus P naught is 0.087 minus 0.065 is 0.022. Denominator is, if you substitute 0.065 and 1,000, you will get 0.008. So Z value, numerator divided by denominator is 2.821. Okay, is it okay? Clear?
Yes. Yeah.
And then this P value for this Z, as I told you, I showed you that graph table there. You can refer the table from the previous template, or you can use this Excel itself. It gives you the value directly. P value is low, therefore reject the null. Clear? Suppose I say here, this one I make it as 0.085. Then fail to reject the null. Clear? Okay.
Yes, sir. Yeah.
So you can, suppose I say here, this is 0.067, 0.068. Then also fail to reject the null. It's so close. Clear? So that is how you do it. You can, please note, sir, is it so easy? Why should I need a template for this? Please note, this proportion is not coming from this, like just like this. You have to calculate from the data. That I have reduced. I am not showing it. That I will show it to you for the next example. Okay?
Okay.
Is it clear?
Yes, sir.
This template I have already passed on. You can download it. Now we will see here another problem. Now, do you see this? Can anyone read it?
Yes.
Yeah? You're not reading?
Okay, sir.
Confidence
read?
trend.
Confidence trend homeware division has been planning to launch a new initiative program for their sales executives. The sales executive have earlier suggested that the men won't buy, women will buy. Analyze the data and determine whether there is evidence at 5% significant level to support this hypothesis.
Okay. Now it is a two group or a population the group?
It is two groups.
Two groups.
Yes. One is a woman group, another is a men group.
Yeah.
In women, so many people are buying. In men, so many people are buying. And in women, so many people are not buying. In men, so many people are not buying. Therefore, proportion is there. Total should be 1 here. So here what I have done is, I have taken male sample as 480 people, female sample as 740 people. That means 480 only came there to that mall. And 740 female people came to that mall. So I was standing in the gate. I told you, no, sample testing. This, what do you call, sample testing by different ways. So easy sample testing, I'm doing it, standing at the gate, and one by one, whoever comes passing, female means, because probably I'm going to female more number of times. So 740 people. And then out of them did not buy was 588. Out of them 488 male, 370 did not buy. The proportion I have calculated, If 370 did not buy, 110 bought. Here also 588 did not buy means 152 bought. That proportion also I calculated. Please note, you can do the calculation either by this proportion or by this proportion. No matter. Result will be same. Clear? And because if one is different, other also will be obviously different. Right? And then how it is calculated, I've given here numerator and denominator, all these things. No need. Please note, and the total sample size, I'm adding it. 480 plus 740, I'm adding it. Suppose I'm making it as 482. What will happen? This will become 1222. Let us see. 482. See, 1222 has come, right? Yes or no?
Yes, yes, sir.
So I'll make it as 480. It becomes 1220. So it is just adding the total. And total sample size is here. And combined purchase is for 370 plus 588 is equal to 958. And this proportion, I am using it. And this proportion also, I can either use this proportion or this proportion. If I'm doing the calculation using this proportion, 0.77 and 0.79, I should use 0.78 as P combined. If I use 0.22 and 0.20, I should use 0.21 as combined proportion. But why am I using combined proportion? Can anyone tell me the logic behind it? What is the null hypothesis? What is the null hypothesis? Proportion of women
both are
and
same.
proportion of men are same. Yes or no?
Yes, sir.
Clear. But the sample study has given me different proportions. Yes or no?
Yes, sir.
Now I cannot use any of this proportion because if I use this some 0.77, I am biased towards male. If I'm using this, I am biased towards female because none of them is satisfying with this condition. Therefore, in order to do fair justice, I will combine the two and then calculating this proportion and using this as combined proportion and then saying that proportion of woman is equal to proportion of man. Clear?
Yes, sir.
Understood?
Yeah.
Right? Now I'm clearly right in saying that proportion of men and proportion of women are same. And that is this proportion. Okay. Now with this, what I do is P woman, P man, I'm calculating. This is 0.79, 0.77. That is 0.77, sorry, 0.79. 0.79 minus 0.07. That is 0.02. This is what is the calculation here. And then here, PC. PC is this value, 0.78 into 1 minus PC divided by, what is the N value? 1220. So I can calculate Z exact value, and this is nothing but this value. Because I have the data, I'm using the data and getting that. For Z value, you can refer the normal distribution, inferential statistics table, and then come to a conclusion. Okay? Clear? Understood?
Yeah.
Fail to reject the null. Suppose I'm making here 700. I'm making it as 700. So what happened? Lower. P value is lower. Reject the null because female are more prone to purchase. Clear? Understood?
Okay.
Now here, again, your question is very valid. Sir, what is this, sir? You put two values, you get the answer. Why should I use this table? Please note, this data 480, 370, 740, 588 is not like this. Raw data will not be, smart data will be coming to you. I will show you the data for this. This is the data. So there are 480 data are there, 740 data are there. This is what will be given to you in real life. And you will have to convert this. What is this conversion? This is called data, right? Data editing, right? So I am putting male. If I did not buy, it is 1. Now, if I make this as so many times, it will change here, and then it will change here also. See here, male, it is 422, did not buy. This 422 will change it to a very high value if I make this. Oh, I have to, I have protected it. Therefore, I'm not able to do it. So if I change this, it will be varying it here. Okay?
Okay.
Since I protect, I should not have protected it for you. Anyway, I will change it and then send it to you, right? I will make it unprotected and then send it to you. Okay? No problem. Right? So this will not, because it is protected sheet. It is reading it as protected sheet. I will change this unprotected and then giving it to you. Okay?
Okay, sir.
What is that? Okay. So is it clear for you?
Yes.
And then this value is what I'm going to put it here. Right, 488, 588 and these things. Yeah. I think I'll stop sharing now. Now we'll go to the totally 4 problems we have done. 5th problem we have to do. 5th problem is what we will do is we will go for chi-square test. Okay. Shall we go for chi-square